Okay, looking at this last proof on the proof packet, what we notice is that the last line, we're proving segments congruent. And the reason for these segments being congruent has to be CP/CTC. And the reason that is, one, we're in the chapter with triangle congruency, so we're going to have to prove triangles congruent. And if triangles are congruent, that means all corresponding parts. For example, side LO and side MM would also be congruent. But the other reason is if I look at these pieces, and I look at segment LO and segment MN, and I go to my chart for my possible reasons for segment congruency, and I go through them. I have reflexive property, which doesn't fit here. I have a definition of midpoint. We don't know this point, which is not named. We don't know that it's the midpoint of either one of those segments. That wouldn't even really help us anyway. Segment addition is not going to work. All these points aren't collinear. So the only option I have is CP/CTC, which means corresponding parts of congruent triangles are congruent. So I'm actually going to work backwards somewhat in this proof. And I'm going to start off with line segment LO congruent to line segment MN by CP/CTC. Now, this is going to be true for any proof that you have in this chapter. If we're trying to prove sides or angles congruent, the last reason has to be CP/CTC. In addition to that, the statement and reason right above that has to be that the triangles are congruent. So our possible reasons here for the triangle congruency are going to be side, 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 angle, side, angle, side, angle, or angle, angle, side. Now, from this statement here, we should be able to determine which triangles we have to prove congruent. If you look at line segment LO is a side in triangle LMO. So, actually, I'll say LOM just so we can use this order here. So triangle LOM has to be congruent to MN is a side in this triangle. And if we went L to O to M, we'll go triangle MNL. Now, if you look at these parts, they match up corresponding order, LO, MN. So we know, or should know, that we have picked the right two triangles to prove congruent. Before we start, if it makes it easy, you can pull those triangles out, separate them so you know exactly what you're working with. You don't have to do this, but this might make things a little bit easier to see. So we have LMN, and then we have OML. So these are the two triangles that we're trying to prove congruent. And what we're given is that angle N is congruent to angle O. That is an angle congruence statement, which is good, because knowing that we have to prove these triangles congruent, and knowing that we have to use these reasons, we have to have three congruent statements, sides or combinations of sides and angles. Now, because we're given an angle congruent statement, and these angles, angle N is congruent to angle O, these being in the triangles we're trying to prove congruent, we know that side, side, side is not going to be an option, or it's not going to be our easiest option. Okay, we also know that line segment LN is perpendicular to line segment LM. And we know that OM is perpendicular to line segment LN. Now, by definition, perpendicular means that these two segments intersect to form a right angle. Now we know that right angle is going to be at L, because if you look here at this statement, these two lines intersect at a right angle by definition of perpendicular. That means they can only intersect once. They have point L in common. So that means at L there must be a right angle. Here for OM is perpendicular to LM, same thing is true here. By definition of perpendicular, these two line segments intersect to form right angles. Now, we are going to skip some steps here And we're going to go ahead and we're going to state that angle L is congruent to angle M. Now, if we separate these triangles, it appears that these vertices are unique, but again, look at them as a whole. We can't just use L and M. So what we're going to say is we're going to say angle NLM is congruent to. Now, if we go N to L to M, we want to go OML, triangle OML. Now, this is a reason that you want to add to your list of possible reasons for angle congruence. And we're going to say that all right angles are congruent. Now, again, we are fudging this a little bit. We're skipping quite a few steps that are necessary, but again, we're skipping those to help really make things a little more easy. To make things easier, so you can see the argument and the main parts of the argument without some of the extra statements and things that might be necessary. The statements would be necessary. By definition of perpendicular, we would have to say that these are right angles. By definition of right angles, each of these angles measures 90 degrees. And if they each measure 90 degrees, that means that they are equal, and then if they're equal, that means by definition of congruency, they're congruent. We're going to skip kind of assuming that you know that if these are perpendicular, these are going to be right angles, and if the right angles are congruent. That really allows us to save a lot of steps and get to really the heart of the argument. So now we have two angle congruency statements. So that means that side angle side is also out. What we do know, however, is our next statement has to be a side statement. So we have angle, and angle, angle, and angle. Now, looking at the remaining sides, we know it's not going to be L, O, and M, N, which now we can see are both the hypotenuse of each individual triangle. Our possibilities are OM and LN. Now, if you look up here, again, our options: reflexive property, no; definition of midpoint, no; segment addition, no; CP, CTC, not here because we still have to prove the triangle is congruent. So what we have left is we have LM and ML. Well, hopefully you see there, and looking here, you can see LM, ML. These are congruent through the reflexive property because they are, in fact, the same segment. So, using the reflexive property, we're able to make a segment congruent statement or side congruent statement. And if we mark that accordingly in each diagram, what we see is by the angle side congruence postulate, these two triangles are congruent. So these triangles are congruent by angle side. Okay? Remember, the order of your arguments is not important. It's the order in which these congruent parts appear or occur in each of the triangles. So now that we have proved these triangles congruent, all of the remaining corresponding parts by definition have to be congruent. That includes OL and MN. That includes angle M here and angle L. That also includes segment OM and NL. But the one that we're concerned with is line segment LO and MN. And those are congruent because corresponding parts of congruent triangles have to be congruent. And that's how we prove and complete the last proof in the proof package.